Hey, welcome back to your favorite trig class. Let's take a look. We're talking about converting from rectangular coordinates to polar coordinates, and so the first step was we were using r squared equals. All right, let me grab the fact that the Pythagorean theorem, right? And then we would set it up with the tangent thing being opposite over adjacent, and we'd use the arctangent and go from there. So this kind of sums that up, and you want to think about what quadrant you're in, because when you run the arctangent of the tangent of theta to get your theta, that theta is spitting out that angle between negative pi halves and pi halves. So you got to think about what quadrant you're in and adjust accordingly. All right, so let's transform the equation now. So we're transforming an equation from polar to rectangular. So an equation from polar to rectangular form. So what we want in rectangular form, we want this in terms of x's and y's here, right? Is the goal. And remember, what we want to remember is we have x squared plus y squared equals r squared, and we also know that x equals r cosine theta, and we also know y equals r times the sine of theta. So when we're given this equation, and notice we have r's and thetas here, right? So we have this equation with these polar coordinates, and we're trying to transform it to this rectangular form. What I'm going to do first is I'm going to multiply both sides by r so I can get r squared, because I know r squared equals x squared plus y squared. So let's do that first. So r this side, r that side. So we got r squared equals 4r cosine theta. And then by substitution, so r squared, remember r squared is x squared plus y squared. So I'm going to make that substitution. And then look right here, we have r cosine theta. What's r cosine theta? Well, that's our x. So I'm going to make that substitution right there. So we got x squared plus y squared equals 4 times r cosine theta, which is x. Okay? So that's our first step. And now what we're wanting to do here, so that's by substitution, is what I'm going to do is I'm going to complete the square. So I'm going to take this 4x over. I'm going to leave a little space there, equals y squared equals 0, because what I'm seeing here is I've got a summation of two, I will have a summation of two perfect squares, which means I'm going to have a standard form for the equation of a circle. So I'm going to complete the square here. So I'm going to take that negative 4 right there, divided by 2, quantity squared. So negative 4 over 2 is negative 2. Quantity squared is 4. So 4 is the magic number I need to add in to both sides so that this factors into x minus 2 perfect square. X minus 2 quantity squared, right? So now we've got x minus 2 quantity squared plus y squared equals 4. Remember, x minus h quantity squared plus y minus k quantity squared equals our r squared, right? This is the equation of a circle. So we have at our center of the circle would be 2, 0, and our radius of this circle would be 2, since r squared is 4. All right, but we put this into, this was the goal right here. We had to get this in terms of x's and y's. We did it by substitution. Right, we substituted after we multiplied both sides by r. All right, now we have an equation. We're going to take this equation, equation. We're going to go from rectangular to polar. So we want to replace the x and the y. And remember, x equals r cosine theta, y equals r sine theta. So, but at the end, we can be in terms of r's and thetas. Okay, so what we have is 4xy equals 16. Remember, x is r cosine theta. So there's our x, r cosine theta. Oops, that's r cosine theta. R cosine theta. That's awful. Y is r sine theta. This equals 16. So we got 4r squared, and we got cosine sine. I'm going to write that sine theta cosine theta equals 16. Now I'm going to be a little creative here for a second. I'm going to write this 4 as 2 times 2. So I have 2r squared, and I'm going to put that 2 right here in front of the sine theta cosine theta. And the reason is, I remember my double angle formula. 2 sine theta cosine theta, that's the same as sine of 2 theta. So I can simplify that, and then I've got 2r squared right there. So 2r squared sine of 2 theta equals 16. Notice everything is in terms of the r and the theta. We just went from rectangular to polar coordinates on that. Okay. Thank you so much for listening. We will see you. That's our polar coordinates section. We'll see you guys next time.